Through the use of implant planning software, virtual implants can be positioned in an edentulous area to yield optimal functional and restorative results. Duplicating the planned case in a surgical environment is afforded through the use of a surgical guide in order to position the implants in the correct location, orientation, and depth. The GRS Guide System, utilizing state-of-the-art 3D printing and vacuum-forming technology, seamlessly connects the precision of implant planning software with the most form-fitting and accurate surgical guide system available. This video is designed to provide an overview of how to create a GRS surgical model to vacuum form a GRS surgical guide when utilizing the implant planning software Blue Sky Plan. After downloading and registering Blue Sky Plan from blueskybio.com, simply click the icon to open the program. At the initial window, select Surgical Guides and then click on Import Patient CT Scan. You can also select the 1 or 2 implant case and will be guided by the Blue Sky Plan wizard, but by selecting the Import Patient CT Scan, each segment associated with the planning process can be better understood and tailored for each surgical application. Once the Load DICOM data window appears, highlight the location of the CT scan DICOM files and click OK. Then highlight the CT scan DICOM volume that will be used to plan this case and click OK. The next window that will appear is the Align Dataset window, which will allow for the refining of the CT scan to provide for greater accuracy and detail when planning the case. By reducing the volume of the CT scan, the anatomic landscape will include only the data selected that is relevant to placing each implant and to later align the STL model to the DICOM data. Once all anatomic parameters have been adjusted, click OK. The implant planning software will then open in the tangential 3 perspective in model editing mode. It is at this time you will also be asked to import additional surfaces in order to align all intraoral data with the CT scan. In this case, we simply need to import an STL model, so by clicking on this option, highlighting the model to be imported, and then clicking OK, Blue Sky Plan will automatically import and align the model with the CT scan DICOM files, requiring only confirmation of alignment with the mandible or maxilla. Once completed, the STL model will be accurately aligned to the CT scan data. If for some reason the alignment needs to be refined, the model can be adjusted under the Model Manipulation panel, and further alignment adjustments can be made in the Alignment submenu. A very simple and highly accurate way to determine if additional refinement is needed or to confirm alignment is to view the model outline as it progresses across the arch and visualize how the teeth of the STL model are aligned with the teeth of the CT scan. This is accomplished by toggling the slider on the cross-section view on the left side of the screen. Further verification can be confirmed by viewing the 3D model and CT scan alignment in a maximized format designed to highlight the blended visual relationship between the STL and DICOM datasets that overlap in the same anatomic space. In this case, the alignment appears very accurate and no adjustments are needed. Now that both datasets have been integrated, we need to calibrate a few variables in Blue Sky Plan in order to create a visually and anatomically accurate virtual environment prior to the positioning and orientation of the implant. First, we need to change the operating mode of Blue Sky Plan. So go to the upper right, left-click on Model Editing, which will produce a drop-down list. Go down to Advanced under the Surgical Guide heading and left-click this option. This will then arrange the display into the tangential 5 perspective and will provide additional software functionality. Second, the curve of either the mandibular or maxillary arch must be established to create a clear visualization of the bone and teeth, which is critical when using implant planning software. Align the individual nodes to format a concentric arch in order to display a clear representation of the teeth and jaw anatomy. For better definition, the viewing mode can be toggled between CT scan slice or a radiographic composite in order to set the arch appropriately. The horizontal axial projection blue line, visible in the upper left cross-section tangential 5 perspective window, isolates the bony topography at a given vertical position across the arch and can be controlled by toggling the slider in the center window axial view. Now, the nerves need to be rendered either bilaterally or unilaterally. In this case, since the implant will be placed at the edentulous side of the left first mandibular molar, only the left inferior alveolar nerve will be rendered. Simply go to the top of the screen, locate the Add Nerve icon with a plus sign, then go to the right and under the automatically open Nerve List panel, left-click on Detect Nerve. Then, go to the Tangential 5 cross-section window and adjust the slider so the mental foramen is clearly visible in the center window. Position the plus sign pointer at the most central and buccal position of the mental foramen and left-click the mouse button. This will automatically generate the left IA nerve position throughout the left side of the jaw. However, if the nerve needs to be adjusted, simply go to the selected window, position the pointer on the nerve, hold down the left mouse button, position the nerve to the desired location, and then release the left mouse button. Repeat this procedure until the nerve position is accurately represented. You can also add the nerve manually by simply deleting the detected nerve, clicking Add Nerve, going to the tangential 5 perspective window, and identifying the mental foramen as a starting point. Then, left-click to place the initial nerve node and using the slider bar to the right of the tangential 5 view to segmentally position nodes along the path of the nerve by clicking the left mouse button until the entire nerve has been identified. At this point, any scatter associated with the CT scan needs to be eliminated. By simply going to the right side of the screen and clicking on the Surfaces tab, then going to the immediate left and turning off the visibility of the STL model under the STL Surfaces submenu, this will provide a clear, unencumbered 3D view of the virtual anatomy from the CT scan. Now, highlight the original CT scan under CT Surfaces, and then proceed to the bottom of the Surfaces panel, and under the Surface Culling subpanel, click on Isolate. Then, go over to the left bottom 3D window, place the plus sign on the body of the 3D model, and click the left mouse button, which will remove some or possibly all of the scatter associated with the CT scan. If any scatter remains or if a section of the CT scan needs to be eliminated, simply go to the lower right and click the Cut button located in the Surface Culling submenu, expand the 3D window, and lasso any unwanted feature of the 3D rendered CT scan. Once completed, minimize the 3D window, go down to the bottom right and click the Cut button to deactivate this feature. Then, go to the upper right and click on the visibility of the STL model. And finally, the integrity of the edentulous site needs to be verified prior to placing the virtual implant. To do this, go to the upper middle of the screen, click on the density icon, and return to the cross-section window in the upper left and left-click on multiple areas of each sub-window to verify the density of the bone as per the CT scan. Keep in mind that this measurement is strictly reliant upon the CT scan and may be clinically different under surgical conditions. Once the density is verified, each individual density measurement can be eliminated by right-clicking on each individual measurement, then clicking on Remove. One optional adjustment will be to change the color of the STL model to something more neutral that will provide improved detail of how the soft tissue relates to the implant position and ultimately the final restoration. Simply go to the Surfaces panel, highlight the STL model, left-click on the color palette to the right and select any color that suits your needs. Once the color has been selected, simply click OK, and the 3D STL model is rendered in that specific color. Once completed, it's now time to virtually place the implant. Begin by going to the upper left of the screen and left-clicking on the implant icon with the plus sign. The Add New Implant screen will appear. At this point, select the type, platform, and length of the preferred implant, indicate either mandible or maxilla, and select OK. The mouse pointer now displays an implant image, and using the cross-section, panoramic, or 3D images, position the implant pointer in the correct location and left-click the mouse button. The implant will be rendered in the designated location, and it is at this point the implant's position, orientation, and depth can be manipulated in both 2D and 3D perspectives. The transparency feature can be utilized at this point as well for both CT scan and STL model to view the implant as it pertains to the patient's anatomy. By highlighting either the STL model or CT scan under the Surfaces panel, the transparency functionality activates, and by toggling the slider bar, the adjusted transparency reveals the implant's orientation as it relates to the patient's oral anatomy. Once the implant has been positioned, it's time to finish by placing a virtual tooth in the edentulous area. Simply left-click the tooth icon with the plus sign. The Add Tooth window will appear. Select the tooth to be restored, select the appropriate size, and if so desired, check the box next to the Align Tooth to Existing Implant and click OK. The tooth will be either automatically rendered in conjunction with the orientation of an existing implant, or a tooth pointer will appear requiring the individual placement of each tooth per implant. Both teeth and implants can be adjusted 360 degrees in infinite positions in the X, Y, and Z planes. Utilizing 2D cross-section and panoramic perspectives, along with the 3D renderings of the CT scan and imported STL model, All implants and teeth can be positioned to yield the most accurate surgical implant placement coupled with the most aesthetic and functional restorative results when using a GRS surgical guide. Creating a GRS surgical model to vacuform a GRS surgical guide is simple. Blue Sky Plan is used exclusively as the primary surgical implant software, and currently we're using the Tangential 5 perspective in advanced mode and have already completed designing the surgical implant case. As you can see, all of the necessary surgical parameters involving position, orientation, and depth of the implant relative to the bone, nerves, and future restoration have been established. Seeing that the implant planning has been completed, go up to the top of the screen and find the visibility toolbar and toggle off all virtual teeth, projections, and locks that may be present. Then go over to the right of the screen, click on Surfaces, and under CT Surfaces, uncheck the visibility of the original CT scan. Then, under Implant List, highlight the specific implant and confirm that the Drill Guide Visibility checkbox has been checked. It is also critical that the specific guide tube dimensions for each specific implant have been manually entered in order to ensure that the selected GRS surgical ring will fit in the designated edentulous area. The dimensions have been provided on this video under the Implant subheading and can also be found at grsguidesystem.com. For this video, we will be using the dimensions required for the regular GRS surgical ring and have made the respective changes to the guide hole diameter and height dimensions in order to validate the fit of the chosen GRS surgical ring. After the fit is confirmed, make sure that the upper surface of the guide tube is visible through the STL model in order to ensure that when a GRS model is created, the hole will extend through all STL surfaces. By default, the guide tube is usually above the tissue level of the edentulous area designated for implant placement, so no adjustments are usually needed. However, to adjust the position of the guide tube, simply go back to the Guide Tube subpanel under Implant List and use the Offset feature to raise or lower the guide tube as you see fit to ensure visibility. Now, seeing you're ready to create the GRS model, click on File in the upper left-hand corner of Blue Sky Plan, and on the drop-down menu, go to the Export To feature and simply click on GRS Model. Depending on the size of the model and the processing power of your computer, the model should be rendered relatively quickly. Once the GRS model has been created, go to the right-hand side and click on the Surfaces panel and uncheck the box next to the original STL surfaces. Then, highlight the newly created GRS model and toggle the Transparency feature under the Materials submenu to visualize the planned implant. Then, go to the top of the screen and toggle off the implant icon. As you will see, this provides virtual confirmation of the hole's position and orientation, which, as you will see, is exactly as the implant was planned. It will also provide you with an example of how the model will appear when printed. Now, once all surgical requirements in the GRS model have been confirmed, simply go to File in the upper left, click on Export Data, select the export quality for the model, uncheck any unnecessary export items so that all you will be printing is just the GRS model as a separate file, and click on Export. Confirm the name associated with the new GRS Surgical STL model and location for the file to be exported, and click OK or Save. Once the model has been printed, simply use a GRS vacuforming assembly consisting of a locator pin, surgical ring, and protection cap to create the most accurate and form-fitting vacuform surgical guides available today. Other videos describing the complete GRS guide system and surgical components, guide fabrication techniques and applications, along with a virtual surgical procedure outlining the seamless step-by-step surgical sequence when using the GRS guide system can be found at grsguidesystem.com. The GRS model is now ready to be printed either in office, by your lab, or simply through GRSGuidesystem.com.